All right, let's continue with our example here. Let's suppose we're going to solve this triangle where lowercase b is 5, lowercase c is 12, and uppercase c is 73 degrees. So all I do is just draw some kind of a triangle for some kind of visual, okay? I don't care about drawing it to scale. I don't care about if it could be an obtuse or an acute one or whatever, okay? I'm going to say this is angle C, so it's going to be 73 degrees. All right, so side C has to be opposite of angle C. So we're going to call that side of length 12. All right, then we have what? We have B and nothing else. Okay, so let me pick an angle for B. I don't know, maybe this will be capital B, this angle right here. So if this is side B, that's 5. This will be angle A right here. And this will be lowercase a, okay? All right, so I have some kind of visual right here. That's all I care about drawing that for. All right, what case am I given now? Let's see, I'm given side, side, angle, right? Because I'm given two sides and an angle is across from one of those sides. Notice that if you were given the angle here, you would have side, angle, side instead. But this is side, side, angle. Side, side, angle, need to look out for my ambiguous case, right? So let me keep that in the back of my head. Could be one triangle, could be two triangles, could be 0 triangles. All right, so let's start out by using the law of sines to find something, okay? I can say that the sine of 73 over 12 is equal to the sine of angle B over 5. Now let's do so. All right, so we're going to say the sine of 73 degrees over 12 is equal to the sine of angle B, whatever that happens to be, over 5. All right, let's go ahead and cross multiply here. So we have 12 sine of angle B is equal to 5 times the sine of 73 degrees. Now let's go ahead and divide both sides by 12 here. So we get the sine of B. Sine of B is equal to 5 times the sine of 73 degrees over 12. Then I say that B is the angle whose side, or the inverse side of 5 sine of 73 degrees over 12. So whenever we put that into our calculator, we get B is approximately 23.5 degrees here, okay? Now remember, the angle whose sine is this stuff. That angle could be in quadrant 1 on the unit circle, where we have 23.5 degrees right here, or it could be at this reference angle at 23.5 degrees. So it could be that angle right there. So another possibility for B, or angle B, would be 180 minus 23.5. 180 minus 23.5 degrees. And what does that give me? That gives me 156.5. 156.5 degrees. All right, so let's see. Do I have one triangle? Do I have no triangles? Or do I have two triangles, okay? Let's think about this for a second. If B is 23.5 degrees and C is 73 degrees, there's still enough room to have 180 degrees in a triangle, right? But what if B is 156.5 degrees? 156.5 degrees plus 73 more degrees is going to be well over 180 degrees, right? So this could not be a possibility. So we would only have B is this value, and we'd have one triangle. Another way to look at this is you could start trying to look at first triangle and second triangle. Could say, okay, first triangle and second triangle. All right, when you would go to calculate the second triangle, what would happen is you would say, all right, I need to find angle A, and this is the assumption that B is 156.5 degrees. So to find angle A, you would say A is equal to 180 degrees minus 73 degrees minus 156.5 degrees. And what do you get when you do this calculation is you get a negative 49 degrees. Well, can A be a negative angle? Draw me a triangle with a negative angle in the inside. It's impossible, right? So, no second triangle. And really, you're doing the same thing either way you do it, okay? So this is not a possibility right here. The only possibility for B is 23.5 degrees. So we only have one triangle. In fact, I don't even need first triangle anymore. I'm just going to say one triangle. One triangle. One triangle where B is 23.5 degrees. And I guess technically I need approximately, because that is rounded. All right, so I have this angle B right here, right? So to find angle A, how do I find angle A? I would say angle A is 180 degrees minus 73 degrees minus 23.5 degrees, and do that calculation. So that would give me an approximate value because that was approximate anyway. And what does that give me? 83.5 degrees. 83.5 degrees. So I'd say A is approximately 83.5 degrees. I found angle A. Now what's left is side A, right? And I can find side A using the law of sines. Sine of cap A over A is equal to sine of 73 degrees over 12. So let's find A. So we're going to say sine of capital A, which we just came up with 83.5 degrees, over lowercase a is equal to the sine of 73 degrees over 12. All right, if we cross multiply, a sine 73 degrees is equal to 12 sine of 83.5 degrees. And if we divide both sides by sine of 73 degrees and put that to our calculator, we get 12.5. 12.5. So lowercase a is approximately 12.5. And I have one triangle that fits that. Now, why did we not have two triangles? Because whenever I tried to calculate angle A, came out with a negative, and that's impossible to have a triangle with a negative angle inside it. All right, so if you have this case pop up, it's going to be one triangle. Now, you might be wondering, how about whenever I have no triangles? How am I going to know that? Well, let's go back to the beginning of this problem, okay? Where we had something like beta or B was equal to the inverse sine of 5 times the sine of 73 degrees over 12. What happens is, if you get something that's impossible right here, it usually what will happen is your calculator will give you an error in that case. Then you're going to have no triangle. And what that is like you'll have some value over here that's impossible. Like let's say that this inside value calculated to 3, okay? Then you would have like the inverse sine of 3. Well, the inverse sine of 3 is, well, it doesn't exist, right? So then you would have no triangles. You would get an error in that calculation there. All right, and finally, we get to area of a triangle. Now, you learned area of a triangle was 1/2 base times height. Yeah, it is. But let's look at a triangle whenever we have this. Okay, so you said area is equal to 1/2 base times height, right? But what if you're given a triangle that looks like this? They say, okay, this is angle A right here. And this is side B right here. This is angle B. This is C. And that's C. And let's go ahead and call that A, okay? Now the problem is, let's suppose they give you these three pieces here. They give you angle A, the measure of that. They give you length of side B, length of side C. If I try to use 1/2 base times height, well, I have the base length here, C, but what is my height of my triangle? I don't know, right? So that formula, just like it is, isn't going to work here. But what if I do something like this? Come with a line down that's perpendicular to side C right there. And I call this the height. And I look at this triangle right here, this right triangle right here. Couldn't I say that the sine of angle A, since I have a right triangle, is H over B? H over B? So I can multiply both sides by B and say B times the sine of A is equal to H, right? Now I could go ahead and use this formula. A is equal to 1/2 base times height. So area is equal to 1/2 times my base. What is my base in this case? C. Times my height. What is my height in this case? B times the sine of A. B times the sine of A. Then I can find the area of my triangle if that stuff is given to me, B, A, and C. All right, and what your book says is, if I want to find the area of a triangle, area of triangle, side, angle, side. So I have side, the included angle, and another side given to me. Here is what I use. I use area is equal to 1/2 times B times C times the sine of A. And I have a couple of different versions of this formula, but they're all the same, okay? The next one is 1/2 A times C times the sine of B. Or the next one is area is equal to 1/2 A times B times the sine of C. But either way, if you use the first, second, or third formula, what is it going to be each time? The formula is going to be 1/2 times the two sides you're given times the sine of that included angle, or that angle that's between the two sides, okay? That's a better way to memorize this. 1/2 the length of the two sides times the sine of the angle between them. All right, so let's look at the example we have then. Let's look at the example we have. It tells us to find the area of the triangle round to one decimal place. And they say capital A is 143 degrees. A is 143 degrees. B is equal to 20 meters. And lowercase c is equal to 16 meters. Okay? All right, let me draw a triangle just for reference here, okay? Just to give me a visual. Here's A, 143 degrees. All right, let me go ahead and call this side B and call that side C. So side B is what? 20 meters? And side C is 16 meters, right? So what do I have given? Side, angle, side. So I'm going to use that area formula. Area is equal to 1/2 times what? The length of each one of those sides, 20 meters, times 16 meters, times the sine of that included angle, times the sine of 143 degrees. Alright, put this in your calculator because they tell you to round it anyway, right? What do you get? Something like 96.3? 96.3. Now, let's think about our units. Usually, area is measured in square units, right? And think about this for a second. Why? Well, what's meters times meters? M squared, right? Or I could say square meters. So when given side, angle, side, use that formula, 1/2 times each one of the side lengths times the sine of that included angle.